I can fight monsters, I can't fight physics.
Hello, Ziad. Thanks for the questions. So this looks like a sort of balancing equilibrium slash moments question. So in the system shown, a light rigid beam pivoted at X is held in position by a string which is fixed at Y. Beam carries a load of 200 newtons. The load is moved towards X. Which one of the following statements is correct? So we've got a pivot here. So we've got a pivot there. Okay. And so let's go by your diagram, even though it's incorrect, but let's go by it. So there's your pivot. That's not what I wanted to draw. Do that again. Here's your pivot. Okay, so here's your seesaw. And then you've got this 200 newtons. And let's call that distance, let's call it X. And then you've got this tension in the string. And let's call that distance y. Now, what do we know? Moments is force times perpendicular distance from the pivot. So y is not the perpendicular distance to the tension. So we can resolve the tension, and this is t vertical. So what do we know? We know some of the clockwise moments is equal to some of the anti-clockwise moments. So therefore, clockwise in this case would be 200x is equal to TV times Y. Okay, so that's your basics. And what we also know, if you think of the tension, it's got a component here, TV, and it's got a component here. And let's call that TH. Now, in equilibrium, the resultant force is zero in the vertical and the horizontal. So vertically, we need something to balance out the weight with the tension in the string. But also, if you think horizontally, resultant force is zero. Forces to the left equals forces to the right. So what do we know this time? We know the forces to the left is TH. So we need the reaction force here to be going, the horizontal component to go this way. So what that means is if you used to draw it again, there's the pivot, there's the line, so the whatever it is, beam. You must have an RH this way, and you must have a R vertical this way, and the reaction force this time is this way, okay, or the resultant of it. If you had to ever draw R and T and W together, that's what it looked like. So let's look at the question. So it says you're moving the 200 towards the pivot. So if you move the 200 towards the pivot, then the clockwise moments decreases. If you move that this way, the clockwise moments decreases. So you need less anti-clockwise moments, and the distance y is fixed. Therefore, TV actually decreases, not increases. Okay, so because clockwise has to equal anti-clockwise. Compression force on the beam increases. No, so it's not compressing. And then the moments of the load about x is increasing. Well, the load is actually, the moments of the load is decreasing, isn't it? Because the distance is decreasing. Well, what we do know, as we said, r vertical plus t vertical is equal to 200. Now, that 200 hasn't changed, it just moved more to the left. Once it, if the 200 was at the middle of the beam, RV and TV will be equal values because they're equal distance apart from the weight. But as it's moving towards RV is going to have to support more of the 200 than TV. Okay, so therefore RV increases, and that's why the answer is D and not B. Okay.